Perfect. So welcome guys. Thank you for coming along to the Thomond's Young Engineer Society's Engineering and Hobbies event for 2022. It's a new event and it's great to have you come along and see what we're trying to do here. We have three great speakers this evening. We have Jeffrey Rowe, who's a computer and electronic engineer, and he is actively involved with Engineers Ireland and Dublin Hackerspace. And he's going to talk about some of his hobbies, which include coding, 3D printing, and building electrical circuits. Then we're going to move on to Rebecca Gleeson, who is a graduate from the University of Limerick. And as part of her master's, she worked on concussions and some research into how concussions can affect players as part of the Munster rugby team. So that'd be really interesting to listen along to, and we'll talk to her in a few minutes. And then we'll have Anthony White, who works in music technology and production, and he's going to speak about how he got involved in music technology and how he came through to work in his career, which reflects what he really enjoys, which is music and movies and so on. So thank you very much to our three speakers. And thank you again then to Dami, who did a lot of hard work in the background to set up this event, and to Rachel for promoting the PR. So well done to everyone. And I'm going to kick off with Jeffrey. So Jeffrey, if you'd like to share your screen, we can get going.
Sure, yeah. I think you have to click unshare, and then we can get going. Turn off your, oh, there we go. Let me find the right button here. Great stuff. Thanks for the great introduction. I guess what I'm going to talk about tonight is how some of my hobbies intermix with my work, and how some things I do in work then influence what I do in my spare time. So a bit of background about myself. I currently work for a small Irish SME called Telclic. I work primarily for them as a software engineer. Then in my spare time, I like to do kind of electronics, digital fabrication, run events, run festivals, and then I'm also involved in Engineers Ireland on the executive and council board member on how this organization is run. So I think we'll jump right into it, and to give you kind of my career path and background. So I finished my university about 11 years ago. I wasn't a great student. I was in DCU originally for 6 years. I guess if you add that up, that means I failed a couple of modules a good few times, which extended my my 4-year course out to 6 years. And then after that, I kind of jumped around a few different jobs. Originally, I was working in DCU as a research assistant, mainly working on software for the visually impaired. Then I decided to try out a corporate job, so I went to work for Google as a site reliability engineer. And then I didn't like the size of that sort of company and working in that sort of atmosphere. So then I switched to more the SMEs, so smaller companies. So I've been in jumping around between a group of 4 or 5 different small Irish companies. They all have a common owners. So I've been employed, I've been working with a similar team for the last 10 years, but I've been jumping around different companies that team own. So one of them is Park by Text. So that was a payments system for allowing people to be able to pay for parking. So I was involved in that as their head developer for a good number of years. We had 200 car parks here in Ireland, across the UK. I moved to Houston in Texas for a couple of months to launch the product over there, until we successfully then sold the company off to Apcoa, and then we kind of exited that and moved into mainly transportation. So the last few years, I've been mainly working on different transportation systems and products. One that you might recognize is the TFI bikes, or it was recently rebranded from the Coke Zero bikes. So you might have seen them in Cork, Galway, and Limerick, and soon to be Waterford. So that's a shared bike scheme that it was that allows the general public to rent bikes and so on. So I was involved a lot in the hardware aspects of that, a lot of the software as well around the electronics and microcontrollers that kind of go into it. Some other products that I've also been involved with is traffic flow. So that's where we manage all the movements down in Dakar, Senegal, in the port. So all the trucks coming into the port, the boats, booking times for getting cargo off the ships, holding areas for the trucks, where to go, basically digitalizing the whole port and enabling Senegal to boost their efficiency in that port and get much more volume through. I'm going to bring it into more streamlined modern technologies. So that's all through an umbrella company called Telclic. So I jump around and do those sorts of different projects. So let's jump into my hobbies and how that all comes together. So one of my first big hobbies is electronics. I studied digital media engineering in DCU, was later renamed to electronics and software engineering. So one of my big hobbies is building electronic things. For the first, say, 5 years of my career, I was mainly doing just software development, web applications, mobile apps, those sorts of stuff. So I found myself, after being in university, loving the electronic aspects, but then having no outlet to do that in my profession. So I pursued it a lot in my hobbies. So I built many different projects over the years, collaborated with artists on lighting installations, bubble machines, giant ducks, robots, all sorts of things. But I guess the one to kind of highlight that I guess probably got the most great feedback from would be the bone conduction machine that I made that called it the School Radio, which I brought around to lots of maker fairs and different kind of events. And what it was is the lady there on your left hand side is trying it out. So it was a metal rod that when you would bite down on it with your teeth, it would send vibrations through your teeth, then through to your jawbone, and then into your inner ear. So you would hear sounds through bone conduction. So it was a great kind of project where people could come along. You see she's wearing her earmuffs there to drown out the sounds, to reassure her that the sound isn't coming through the air, that it's passing through those vibrations of that motor that's vibrating that metal rod. So it was a whole kind of project to marry the right size motor to the right size amplifier, a small embedded Linux server to play the sounds around music. But it was a great kind of avenue of lots of different aspects to come together, be able to build a project. Then when I moved out of the parking field, I could then start using the electronic skills that I did in university and that I kept going and kept up to date because of all the hobbyist projects that I was doing, that I was able to greatly contribute to all the electronics that goes into the bike share scheme that has 100 stations at the moment in Ireland. So there was in the photo there's a PCB designed for power distribution. There was cards on the system to read RFID tags, to press buttons, to detect bikes. So it was a great opportunity that I didn't feel that I needed to ramp up or upskill too much, because it wasn't like some other aspects of my university course where I hadn't come back to the topic for 6 years, and there was no that ramping up period because I had kept it going as a hobby. So some of my other hobbies would be around digital fabrication. Primarily, I usually kind of focus on laser cutting and 3D printing. So on the left here is, I think it was 13 hours of a print for a headphone stand. So a nice set of headphones could stick on. But these were all kind of desktop fabrication equipment, so 3D printers and laser cutters and that sort of stuff. I didn't think that after I've owned a 3D printer now, it must be 5 or 6 of them over a 10-year period. I never thought in my day job it would come primarily working for a software solutions company that we'd ever incorporate 3D printing into it. But we had to have a part produced for the bike scheme that we managed. So the photo on the right there is a 3D print of a model before it would go off to manufacturing. So it would go off to be cast in aluminium. But it was because I had the 3D printing experience, and it was mainly just printing widgets and stuff and figurines for myself, that I was able, for when the topic came up in work, how are we going to prototype, or how are we going to get something made for this part? I said, oh, let's try out 3D printing. So I was able to use the same, Autodesk tools that I was using at home. I was able to bring them in, work with another designer on getting the parts designed, and then 3D printing them so we could have a good test fit that you see on the right there as a test fit on the bike before we go to the long process of manufacturing. So another one of my hobbies, and probably, my slides, there we go, it was a bit of a snag. So another one of my hobbies would be security. So even before university, I was big into my war games, film, sneakers, all this, atmosphere of computer security, the hacking films, all that kind of, writing computer code to, get free Wi-Fi and all sorts of messing around with information security. So even before engineering and all that stuff, I had a keen passion in computer security. So even though, so for the first, say, six years of my career, I didn't really have that much to do with security. But then when it came to rolling out a new version of these public kiosks, our client, the NTA, had the requirement that anything that we put that was public facing would have to be what's known as pen tested. So it would have to be security tested. So nobody could pop a dodgy USB key in the side and be able to get free bikes or stuff like that. So because I was going to all these I had the background in following the security, computer security as a hobby. I was going to different conferences, even though I wasn't working in the field. As I kind of said before, I found I could jump into this new project that I had in work, where the idea of securing this touchscreen, this Linux computer here, and securing it in a way that could pass the client's requirements and produce a secure product. So I guess the general theme that I'm going for is to kind of showcase that you're picking up and you're maintaining expertise, even if you're not working at them every day in your job. But some of these expertise that I maintained would have been hobbyist projects and stuff like that. Another one here on the screen is, so on the right there is one of my trips to Senegal, when we were building a lot of the infrastructure around the port. So you can imagine there's barriers, there's cameras to detect the traffic flow, there's sensors in the ground, all sorts of IoT equipment that we were putting in place. And we were coming up with problems like per internet connectivity, unreliable power sources in the area. So I had been building kind of low power devices. On the left there's kind of a video trailing through of a weather station that I built in my back garden. But I guess when I was building that weather station, I was going, well, I don't want to provide internet all the way to my house. What do I do if it doesn't have power or sort of stuff? So some of the problems that I faced on a hobbyist level, so learning about, for example, LoRa, which is a low-powered communication system for IoT devices, or Sigfox, and handling data from sensors, kind of gave me a great stepping stone when it came to working on that problem, and we were putting in all that infrastructure in Senegal. So I knew what were the latest devices and what were the trends in the industry to bring to that project. And it's been up and running in the port now successfully for a number of years. And yeah, as I said, it's another great example of following this passion and hobby, liking electronics, and then these projects that come along and work, they might only come along, twice a year, where I have a project where we get to do electronics, do some 3D printing, do some IoT devices. The majority of my time, I'm still doing my regular job of software development. It's only these kind of special occasions where I get to do the other kind of interesting hardware projects and security projects. And then I guess another thing, let's look to the next slide here. I think it has a bit of, I'll give it a second to switch. I don't think it likes you switching when there's a video playing.
It hasn't bounced yet. There we go, yeah.
There we go. I don't know why I put so many videos in it. I'll know for next time. Okay, so all these hobbies, really the reason why I do them all is because I like doing science outreach. So I like going to events and like the Young Scientist, or running an event for Engineers Week, because I generally have a passion for peer-to-peer education, science outreach, inspiring the next generation to take up a technical hobby or follow engineering as a career. So over the years, all these hobbies have kind of focused around doing outreach. So one of the logo there in the top left is Double Maker. It's a festival myself and a few others started about 9 years ago, that we give people a place to showcase and to show off their making hobbies. So people who do wood turning, robotics, all that sort of stuff. So we give them a day out in Merrion Square. It's great for me because it gives me a chance to do more project management, event production, budgets, PR, lots of those kind of other kind of soft skills that I don't just do when I'm typing my Java code and making software work. So these kind of outreach events and these festivals, and as well the Makerspace TOG that I run, that brings people together and we do events in there, that kind of all helps me develop these soft skills, and also gives me a place to showcase some of the projects that I've mentioned earlier. So the video on the right there is a science camp that I went to before the pandemic, it was 3 years ago, where we did a bridge building event. So you can see my friend there, Christian, is destroying those poor children's bridges that we just built. But yeah, I got a real passion for doing outreach. I find it very fulfilling. It inspires me to the benefits and the joys of this profession as a whole. So then I guess what we'll deal with this sort of, it flipped over quite quick. So what I'm going to guess was, what I would suggest to all of you is to take up a maker-related hobby to go alongside your professional career. It doesn't have to be technical. It can be where you take up a crafting skill or carpentry or something. One of those kind of physical making projects that you produce something, or you have an end product at the end of it, and then go and showcase that project. And I think it gives you lots of auxiliary skills that I mentioned earlier that your company or whoever you work for might end up utilizing, like they have in my case. Or it helps you produce those other skills, like making a project to a particular deadline. When you're following your hobby, I'm sure you don't have unlimited budget to follow your hobby. So it inspires you to find other ways. So on the screen is just various different projects and events that I've been involved with over the years. So like air quality sensors, laser cutting, some pictures from Comic-Con a few weeks ago when we were building costumes for it. So just kind of be creative, build, find a hobby that you like, making something. And I think it'll benefit yourself, your career, and allow you to be, you know, inspired and recharged more time than not. And then just the final slide is, if you'd like to get in contact with me, my Twitter address is, you can contact me on Twitter. My email address is there. Some links to some of the organizations and festivals that I run around screen. But yeah, if you have any questions, throw them in the Q&A section, and I'll be around at the end to answer anything you have.
Thanks, Jeffrey. That was really interesting. Yeah, just any questions, can you please put them in the Q&A, and we'll come to them at the end. I know there's one or two there at the moment. That's great. That was really interesting, Jeffrey. I'll come back to you at the Q&A, and we'll have a bit of discussion about some of the things you talked about. But you hit some really good points and kind of got the whole idea of what we're trying to do here, which is just to broadcast that hobbies are useful, not just for self-fulfillment, but also to teach you soft skills, critical thinking, and to keep your skills fresh, even though you mightn't be using them every day at work.
Yep.
So Rebecca, if you want to share your screen, we'll put you up next.
Yeah, of course.
Again, as I mentioned before, Rebecca is a biomedical engineer, and one of her interesting topics she studied in university was concussions, and hopefully she can talk a bit more about that in her presentation. So
yeah, of course. Sorry, I'll put this in the corner. Hi, so as Greg said, I'm Rebecca Gleeson. So I did biomedical engineering as my undergrad. I have a master's in mechanical engineering. At the moment, I work in process development for Boston Scientific. So I know the topic here is hobbies, and they're a really good way to sort of figure out what you like and what you don't like. I know myself, it might not be the same for everyone else, but when I started engineering in college, I didn't really know what I was getting myself into. I had a vague idea of what an engineer did. I had a vague idea of what I might like to do with my job and my career afterwards. But really, I was just going into it blind, because I don't know about anyone else, but I had no engineers in the family. I didn't really know anyone in the field outside of the family. It was just, you know, it was sort of a new frontier for me. So what I tried to do was try a little bit of everything and sort of find what I enjoy. So the first big project where I sort of got to figure out what I do and don't like was in my undergraduate for my thesis. I know you'd think in 4 years I did little side projects, but nothing really hit. Nothing really called out to me. But the first thing that did was when I started researching bone cement. So I don't know if anyone knows, it's basically when people are getting prostheses, they need something to fix them. So again, it's cement. So it sort of keeps the implant or whatever it is they're putting in you in place. The side of it that I really enjoyed was the practical side of it. So in college, a lot of the work was theoretical, and the practical aspects were sort of group work and teamwork. And you didn't really get to really delve into it because, again, the projects were sort of over a couple of weeks. You'd maybe get a month to do it before you had to submit it. So you couldn't really like deep dive into it. But with research projects, you have, I don't know, the bones of like 7-8 months. So I was in a lab all day doing bone cement research. I was working with people who were working on adjacent projects that were related to it. I really enjoyed that. I liked the teamwork, I liked camaraderie, but I also enjoyed being able to do my own thing and to sort of research around the topic. But then at the end, I realized I don't actually like the topic as much. I didn't really enjoy material science. And then when it came time to choose, well, actually the pandemic hit and I thought, oh, I might do a master's. I was looking into the biomedical master's courses and they were all sort of material science based, and I knew I wasn't going to enjoy it. It was just going to be torture for me. So I sort of had to pivot, and I was asking around. I was friendly with some of the lecturers in college, so I was asking them their own opinions and what they thought I should do, and they were sort of like, I mean, you could go into mechanical, it's nice in general, you might be able to get a good research project and work off that. So that's what I did, because pandemic, time to kill, might as well do this. So I actually got very, very lucky with my research project for this. So this is the concussion research project that Greg mentioned earlier. I always sort of had a fascination with the brain. I wouldn't have had a lot of time to dedicate to studying it, but I was always sort of intrigued by, what makes you tick. And I know that's a bit more psychological, but I didn't realize that there was a whole other aspect of it that is studied, but not necessarily by engineers. So the opportunity came where I could study concussions. I'll talk about that in a minute. I'll go to the other points. And piggybacking off that concussion research and my research with the brain and all the work I did with that, I managed to get a job on a neuromodulation team in Boston Scientific down in Clonmel. So basically, I help like to design the processes and sort of design the actual sorry, I'm trying not to use technical jargon, the thing that you put inside of you, the device, to help regulate people that would have the shakes from Parkinson's, things like that. So that's the main project I'm working on at the moment. But then I'm also working on side projects that are also related to the brain and how to sort of get the brain working normally again, if that makes any sense. I also work around that as well with volunteering. So I work with Junior Achievement, which is basically where industry professionals go into secondary school and primary school settings and try and encourage those students to look at engineering and to look at other like STEM pathways as an option. So I was quite lucky this year that I was placed with an all-girls secondary school. So when I first started, I asked if anyone knew what engineering was, and no one had a clue. And they were all sort of shocked that I was an engineer. And I know it's sort of a very topical thing for women in STEM, but it was nice to actually see like young girls realize, oh, this is actually a pathway that I can go down, and it's something I really enjoy. Part of the junior achievement is that you do weekly projects with the kids, and they're all engineering based. So they got to see different subsets of engineering and different ways, basically just different careers that they could possibly go down. So that was quite fun. We actually, Engineers Ireland also works really closely with STEPS, which is a similar program. And then I also work really closely with Society of Women Engineers, both globally and within Clonmel specifically. So that group is basically trying to improve conditions for women working within STEM, to sort of bring awareness to like making teams more diverse, to promoting women into higher roles, to keeping women in the teams. We like women in STEM tend to drop out of the profession at a certain level. The actual reason for it is sort of unknown. It's a bit wishy-washy, but basically that group sort of tries to encourage women to stay in the position and figure out what they need to stay and to actually bring more value to their team. Because, the more diversity in your team, the better the project's going to be, because you're going to have different vantage points than everyone else. So, I'll just go on to the next slide. So part of engineering, well, when you first go in, is trying to figure out what type of engineering you actually enjoy doing. So there's loads of different ways to do this, experimenting within group projects, experimenting outside of college itself, networking with different people. So not necessarily professionals, but people in different courses within engineering. So say you're a biomedical engineer like I am, talking to someone in aeronautical engineering, seeing if you like what they're doing. And there's lots of modules that cross each other in college. So if you haven't met anyone from a different engineering discipline, you might meet them in those modules and sort of realize, oh, maybe I don't actually like biomedical, I'd like to go into an aeronautical, things like that. And then, so actually delving into your own hobbies and realizing, oh, I like, video games, maybe I could be a graphic designer, things like that. So once you sort of figure out what your niche is, which is, a combination of what you enjoy doing, what you're good at doing, and what problems that you as an individual can solve, and obviously what people are willing to pay for is also quite important if you're going to use your hobby to sort of piggyback on your career, if that makes any sense. So part of exploring that niche, you can use online resources. The internet's a great thing. Everything's there really. You can sort of tap into those global networks. So people in college may or may not realize that all the universities are linked in some way. So you might be able to connect with someone in DCU or UCD, or even abroad in the States or somewhere in Spain. Like all of these clubs and societies generally have a higher up level that you can make your way up through and then sort of filter out again or spread out further and sort of figure out people or find people that are like you, that like what they're doing, and you can sort of communicate with them and figure out if you like that too. So LinkedIn also is a really good resource. Talking to your colleagues, that's not necessarily your work colleagues, but other people in your course. If you sort of branch out of your own friend group, you might realize, oh, this other person in my course that I really is really nice. They do this in their evenings, and I want to sort of delve into that topic and join them and do that. And the same with the clubs and societies. So yeah, so oh, sorry. Part of engineering as well is sort of expanding on your existing hobbies, like Jerry was saying earlier, things that you would do in your own free time that you won't necessarily realize could be linked to engineering. So yeah, so the first one here said a big hobby for people is physical activities and sports. So that links in with my research project that I did for my master's that made me realize that I really do enjoy studying the brain. Obviously, I had done in the past, but it wasn't, again, a deep dive because I didn't have the time to dedicate to it. So yeah, so my niche is the brain. So when you do a thesis project for engineering anyway in UL, you get a big long list of all these topics, and you get the contact information of the lecturer and basically the title of that thesis. So as I was reading through them, I realized, John Mulvell, I don't know if anyone who goes to UL, he was the one heading this, and I quite liked him as a lecturer. He always gave really interesting classes. And then I saw that it was to do with the brain. I was like, oh, perfect, that's what I'll do now, that's great. Once I started it, I realized it was really heavy on CAD and on FEA. And those were softwares that I hadn't really used as extensively as someone who would have, say, did mechanical engineering as their undergraduate degree. For biomedical engineering, it's lots of fluid dynamics and things like that. So I had to use my network and sort of learn how to use these softwares. Obviously, I had an idea how to use, or I was familiar with SolidWorks, but finite element analysis is another thing. So that uses Abacus, and I had little to no experience with Abacus at all. It's, I guess, an easy way to describe it is it's a fancy SolidWorks, because again, you do design on it, but you can analyze impacts and things like that. So that's what my research was. So what I did was I got an MRI scan. I had to upload it into Abacus. I had to design the brain inside the MRI. I had to sort of sort out its boundary conditions. I had to sort out, basically, I had to make a brain on my computer. I had to learn all about the different materials of the brain and how it's made up and sort of like their level of hardness and things like that. I had to try and make the software work together. So if anyone has had multiple parts in SolidWorks, you sort of know what I mean, and trying to get things to fit together. If you're a couple of millimeters off the whole thing, you have to sort of restart your part, which is sort of annoying. And so, oh, sorry, I'll go into this. So this is one of the models that I ended up with. So I had to go layer by layer for the brain, and then I had to mesh it together. So meshing is a part of Abacus that lets whatever force you apply on the model sort of travel through. So I don't know if you can see my mouse, but basically if you put some pressure on here, you can see how it travels all the way into the middle and out again on the other side, depending on the material and the density and all that sort of stuff of your different layers. So the reason why my specific topic was important was because the existing models of the brain don't necessarily go into all the different parts. I actually got rid of that image. I realize now why I put it in the first place. So what current models of the brain, or current 2D models of the brain, only have the actual brain and then the outer shell. Maybe you'll get 2 layers. It sort of depends on the paper. But no one had done all 7. So working your way in, basically the whole way through, there's about 7 layers, and they all have their own materials, densities, boundary conditions. Basically, they're all pretty much they're a whole new thing. So I had to model that and mesh it. And basically, what this research shows is what the sudden impact is, and then the long-term implications of that impact. So Greg was mentioning that earlier, this was sort of related to Munster Rugby. So Munster Rugby work with John Mulvell to try and figure out if the rules and regulations around returning to play after you get a concussions are correct. So at the moment, there's about 5 stages for rugby players to return to play, and those 5 stages usually happen within about 2 weeks. What my research and other people on my research team found was that 2 weeks isn't necessarily long enough. Part of someone else's research was that they modeled the hormone rise and decline of basically when you get a concussion, certain hormones spike. And they basically took the bloods of the players who had a concussion and monitored those spikes over 2 weeks. And they found that usually for the average professional rugby player, it took about 3 weeks for their hormone levels to go back to what they normally were. So basically this information was used to make recommendations to the Irish Rugby Rules and Regulation Body. I'm saying their name wrong. There's definitely another name for them, but I can't think of it at the moment. Yeah, so my hobby of, being sort of oddly fascinated with the brain worked out well for me in terms of my research project, and it made me really appreciate the time and effort that I'd put in and other researchers had put in to study this topic. And it benefited me, long run, because I was able to talk about it when I was looking for jobs, and I realized that Boston had a really big neuromodulation department, and it made me really it basically made me a bit of a shoe-in because I already knew so much about the topic. But of course, you don't need to know everything about a topic to get a job. But it certainly helped whenever I came into work and I could sort of seamlessly fit into conversations about the devices that we were making and the different ways that they work. But yeah, so sorry, I didn't flesh out my slides very much. But there are other hobbies that you have that you might not necessarily think are engineering based can always really be turned into engineering hobbies. And they don't necessarily, again, you don't necessarily have to have a hobby to be into engineering, but it certainly helps if you have a passion for a certain subject and you can really dive into it, because there's 101 companies in the world and all of them do something a little bit different. And it's just really about finding that company or that team to sort of monetize on the hobby that you love. But then again, you have to be careful that you don't put too much time into it, because then you might not have a social life afterwards. As the guys know from earlier on in the call, the second I opened my laptop, I got a couple of work emails. Yeah, it makes your day a lot easier if you're doing something that you actually have a passion for. But then again, you have to make time for yourself. And I think I'm sort of rambling at the moment. So if Greg, you want to stop me.
To cut you off, yeah.
Yeah, if that's okay.
Yeah, no, that's really great. Thanks for that, Rebecca. So I suppose what you've shown there is that if you're really keen interest in sport, as one example, or it'll be music now for Angie in a second, but there's lots of ways that you can contribute without actually being the person on the pitch. Like for example, you have Formula One, you have engineers designing the car, everyone understands that. What people forget is there's GA clubs for nutritionists, you have Rebecca here looked at concussions for rugby teams, you have people designing bikes to be more dynamic or better for road racers, you have rally cars, then you engineers. Like there's a whole range of sports and hobbies that engineering is a really big part of, and people sometimes forget because you only see the really gifted musician playing the piano. Like there's a whole acoustic design to even how the piano works, or even to how the whole room is designed to reflect those sounds back to people. And I think Anthony might get into more detail on this next. So Anthony, I'll put you up next if you want to share your screen. And
yeah, perfect. So,
get cracking. Thank you very much, Rebecca. That was great. And again, any questions, can you please put them in the Q&A and we'll get to them shortly. Thank you very much.
You can see that okay, yeah?
That's working perfect, yep.
Yeah, perfect. So just to bear in mind, it's going to be very basic PowerPoint, and I'll basically just flesh out what I'm saying. So I'm just basing off my own experience, really, of how I got started into the business with the sound engineering and music technology. So how it started for me was I began acting on stage since I was 10 years old, roughly. mostly musical theatre. I was at it for a good few years. And then I loved the idea of performing, even if it wasn't just acting, just even dancing and singing. Just the buzz off the crowd, everything like that. And then you just learn different things as you go along. Like, for example, you learn like set construction, backstage work, how a show works, how everything just comes together. But it's quite a lot of time, very time consuming. But for myself, in regards to music, I love a lot of genres, mostly hard rock, heavy metal, opera, classic, pop, a lot of different genres, which is great to have, because when you're in this type of industry, you can never be against one genre, because you might have to mix a song, for example, in the genre, and that kind of thing. But basically what happened then with me was I was a big fan of Michael Jackson. So I actually took that to another level of performing, mostly just dancing as an act. I did that for a couple of years, mostly charity events. And how what happened was then, how I wanted to learn more, see, I'd be organising my own set list for the songs. So say with the music editing for different tracks, how to flow into one another. I didn't have a clue how to do it. So I had to do a very basic concept like using iTunes and everything. It wasn't very sufficient and it wasn't very reliable, but it worked in the end, thankfully. But that was just out of pure luck, basically. So I always had a hunger to learn something. It was really annoying if I didn't know something about learning it. So what I done was then, I finished school in 2013. I took a career break for a couple of years, and eventually then I actually realized I'd like to learn more about the production side of things, mostly in audio. So what I done was then in 2015, before I started college, I ran a charity concert. It was actually a Michael Jackson concert, an event. I directed and choreographed it, organised everything, marketing, finance, sound and lighting and everything like that. But that went off well. So I'll just go on here because I'll show you pictures in a minute on that. But I joined a PLC course then. It was a 1 year, is music technology. And what I done there then, I was thinking, will I go to college to pursue it further, because I still want to do the acting, but then I said I would. So when I went to LCFE in Limerick, I then went into LIT for 4 years. Now, the great thing about the course there is you don't have to do the 4 years. You can do the 3 until you get your degree, and the 4th year is optional. But I did the 4 years because why not? And also get experience in between. Now, the reason you'll hear a lot of it if you get into this type of industry is networking. You really, as much networking as possible to build up your contacts. A lot of people you might meet in different areas of the industry. I go through different areas that I explored with studying mostly and getting to know different people and how it's helped me as performing, especially like. So just as explained here, I organised 3 charity concerts, so I have a bit of familiarity with each sector. So I'll be directing, the financing and marketing, and many other different ways. Whether it's designing posters, your advertising, organising. It's all about organisation, to be honest, and communication, and write everything down in a business, because it'll backfire with certain things. And just move on from there. Things are changing up. It's a bit slow. Okay, so that's one of the concerts that I done. That was back in 2015 before I started college. It's just a short still of it, basically the production of it. So I got the set painters to paint in some of the set. I think that's carbon. I can't remember what's pushing out these geysers. Basically, just give that big smoke effect. But it was very interesting. Like at the end, I even added in a tank, got it built just to bring it on. It's kind of how I felt I set up my career-wise to get into the industry and learn a lot. Like you'd be surprised how much you'll actually learn when running an event. Just having a music event, even a conference event or anything, you'd actually learn so much. I'd encourage people to do it if they could. But bear in mind, it is very time consuming and you have to put a lot of effort into it to work well. So that was the first event that I done. And after a while then I decided to do 2 more. One was in 2019. And then another one then, it was 7th of March 2020. So basically 5 days before lockdown. So I was very lucky to get that done. I've pictured that in a second. But like basically what it bound down to create more opportunities. So I explained the production more in depth. So when I was doing my first concert, I didn't have a clue what a PA system meant. Basic PA system is like speakers with a mixing desk and a microphone, that kind of thing. That's the basic way of saying it. So I'd probably be the perfect example to explain, like, you don't have to be very nervous getting into the industry if you no experience whatsoever. If you start from the ground up, you'll be fine. I had very basic knowledge of playing an instrument as well. So you don't have to play an instrument, but it would help. If you don't play any instruments at the moment and you're looking to get into the music, I say piano would be the best place to start, because you can compose away on a keyboard in a studio workstation. And I go through that in more depth as well. But sorry, I don't know why it's not changing there. Oh, let's come back to the far. And that's just still from the last concert 2 years ago. That went off well, production-wise. I think there was a nervous around the place just with the virus coming in, but look, we won't get into that. You know how that played out. So this is one experience I've done. It's in the Fela Festival in Thurles, late 2019. So on the left picture there, that's just the front of the stage. We had to put down some of the pallets. But at the start of the day, we started rigging up the lights into the truss. There's a lot of people involved with this. Speakers came in. I don't think they came in that day. I think it was later on. And basically connect them all up, wiring. And when you're in a business like this, the rule number one is health and safety. I say it's the same across a lot of the engineering industry, to be honest. If you never feel safe to getting up on a height, don't do it. No one would expect you to do it. Like you see in the right picture there, that's during a concert. I can't remember who's playing that one. But you can see it's just big production, and it was just nice to see that side of things, because I'd be more used to smaller events, like an amateur production of a musical theatre side, maybe some bar gigs that'd be worked at or something like that. So it's nice to see some sort of festival size like that and the amount of people that's involved with it. Let's see. So I don't know, it's taking ages to change. And so there now is on the left picture, if anyone's a fan of Tin Lizzy, that's the original drummer. Brian Downey is playing the drums with his own band, Alive and Dangerous. It's great to see. It's just fantastic, especially for Frank growing up watching that. You're basically, what we do is between each act, you're dragging on different speakers and amps, connect them all up, and you're kind of do it within a minute or two, and make sure everything's set. It's intense. If you can work under pressure, you'll actually get to enjoy it as well. You've run off the adrenaline. And then just the right picture is just basically one I took. And I got to meet Dustin the Turkey backstage as well. It's good crack. It's nice to meet it. But this picture then, this is when I was in college in LIT. What we do is just, this is with the lighting. So we get up on top of the scaffolding. You're very secure, a safe environment up here. So what we did is the profile light, you're basically just trying to focus into a certain location. So the stage isn't very dark throughout performance, basically. You might have to replace a light, take it all off, replace a different one. It could be damaged or a bit cracked or something like that. Or you might need a different color, which is basically called these gels. So that's just one, and that's the scaffolding, say, from the front of the house to the stage. And then later on, then you'd be on the actual stage, you might use a ladder or a thing called a tower, which this is basically it. So basically legs are in place, you make sure they're dead center. And then it's monitored basically. I think it's battery operated. And you just basically pull a lever and just go up and just set it. But then again, if you're afraid of heights, you shouldn't do anything like this, because you'd have to be safe, feel secure and safe in there. Because it is up quite a height, just focus these lights in a safe environment. As you can see with the high vis and the hard cap on. But yeah, so look, just moving on from there then, obviously when the pandemic came in, I had more free time. I was working from home, but then I got sick of the job and I wanted to explore different parts of the industry. So I done was with Griffith College. It's an affiliation with Pulse College. It was a music composition for gaming. Now basically you could also say it'd be for film as well. So basically you're scoring music to picture. in software. So how this works then is that's just a book I'd recommend to people, A Composer's Guide to Game Music by Winfred Phillips. If you're into gaming at all, it's even very interesting read. But it's great to learn how she even got started into the industry of composing music for games. It's very complex, actually. I have a link to YouTube there. I'll just play 2 minutes of it there. I won't play the whole thing. You can see that okay, can you, Greg?
Yep.
Yeah, perfect. Okay, I'll leave it there for a moment. But that's just giving an example. That's what we do for one of our projects in the course. Now I'd be very basic playing piano with that. So I'll just go through how that works. Basically, this is a MIDI keyboard, and this is what I have. It's very small and simple because I'm only limited to a certain amount of space. These keys, they're not essentially notes, they're called MIDI messages. So what to do is you connect this to your computer with a USB cable, and they send a message to the computer, and it could be used different ways. So for example, you could load in a violin and play the notes of the violin. You can play it in a short note, a long note. It could even be used as percussion, any different instrument you could have on it. Now what they'd be called would be software libraries. So it depends, it costs a lot depending on the library package you get. But not to go into full in depth about it, but just the way you can articulate it, sustain it longer. You'd see a lot in films like with Hans Zimmer, just for example, in the Dark Knight film, he really suspends a bow and a cello to give the sound of the Joker like very intense. He might just play one note and just sustain it out, and like it's going to snap. That kind of a thing. Look, there's so much you could do. It's all that creativity. If you have any more questions, you could drop in an email later on. I can put it on there, no problem. And this is just a screenshot of basically a software. It's a digital audio workstation, also known as a DAW. This is called Logic Pro 10. This is Apple software. So if you've got a MacBook and you're looking to get with Logic, you can get with it. Now, if you want to buy it separately with a MacBook, it's like 230 euros. But it's basically considered like professional software that you can use. To use this everywhere. Now, there's loads more. Pro Tools is another one. That's basically they call it industry based, but all more or less do the same thing. It depends what way you use it. Like I don't use this for mainly composing, whereas if I was editing or mixing, I'd use Pro Tools or something like that, or maybe recording. It just depends. Really, it works differently for different people. Then you have your mixer. You can watch your levels while you're playing through it. You usually have a separate window, but it's just to give a little window for it while you're going through it. And this, when I finished the music course, then what I was involved with that was sound design as well. So a lot of Foley, which means like sound effects for a film, like you're making footsteps. You might be create fire, like so maybe you might layer sounds together. Same thing with gaming. They give us this software called Unity, which is a gaming engine. Some games out there would use Unity. can't think of offhand, but so you're basically putting this like this field, you can expand it out as long as you want to the certain region where you might play that sound. So if you're walking along, just say on a beach, and there's a lantern there, you can hear the fire going off when you walk away. It's not there, kind of thing. It's cool. It's like a 3D spatial environment and everything like that, and how the music changes going from one area to the other. So this course, then I said, this is up till about July 21 last year. Only lasts for 16 weeks. This is an AV course for technologies. So it's mostly involved with this, be live for live events. So it'll be similar to my degree, but more in depth in certain areas. So I learned more on videos, which I never done before, like video cameras, and how you can switch between cameras using a thing called an A10 mini controller. So if you're on a live stream, just say YouTube, and I had 3 different cameras set up, I can change it certain ways. So like we had a band there now, and we had 3 or 4 different cameras set up, and it's just the control room in Windmill Lane Studios in Dublin. So there's a lot of big artists around there over the years, Rolling Stones, Def Leppard, Lady Gaga, Ed Sheeran, loads. So it's really cool to be in there, to go through all that. We didn't actually use that big mixing desk there. But the setup was very cool being in there now. That's just the setup again now, the performers. You can't see the camera setup because I took it in front of it. That's just me there. So you can see the small mixer there on the left. That's what we use then for the sound, to control what's going to come through on the live stream for that. So basically, this all basically just came full circle just because I wanted to be an actor. Because I feel it really helps your performance when you know a lot of production side of things with the audio, the lighting, how everything is set up. And you basically can control yourself. If you want to ever do anything at home, you know how to set it all up, kind of a thing. That's just basically the courses that I did do. Like I started off in 1 year, did Limerick Senior LCFE, used technology. If you wanted to get to know this industry without doing full degree, I suggest maybe doing a short-term course or 1 year course in that area. Because if you find after 3 or 4 years you're bored and it's not there for you, it might be a waste of time for yourself. Whereas I say, if you just do an introduction course and see what areas you could explore. Like I always liked live events, but I think I got more into the studio work with the music composition, with gaming and sound design really. But everyone is different. I'd still like to do the live events myself. But it's not just them type of areas you could explore. Like if you've done a master's after a degree, you could get into audiology. So working like in opticians and fix hearing aids, that kind of a thing. And like we did a bit in biology, like studying a bit of the brain, the ear, that kind of a thing. So like different courses, they explore through different areas, and it's nice to get a taste of each thing to see what you actually be really interested in. Yeah, that is more or less it. To what I'm bound down to, but like I'll leave the YouTube link there from if you want to hear the full piece, and my email if you want any other questions after that. That's it, and thank you for listening.
Well done, Anthony. That was really good. So just to kind of summarize what you've said and what everyone said is that, these hobbies are really important for developing your soft skills. Like Anthony's talked about, you're managing people, you're talking to suppliers of equipment, you're trying to manage different teams, communication, time management, self-motivation. And also you get a chance then to freshen up your technical skills. You get to use software like musical development software. Jeffrey's using 3D printers and AutoCAD design, SolidWorks, which is something Rebecca had to use in for her project, and she probably uses in her everyday job. So it's great having these kind of hobbies just to kind of complement what you do in your everyday job, while also getting a bit of a creative freedom to do what you want to do, as opposed to always having to do what you're told to do. So it's great. So thank you very much, guys.